Hi, in this video we're going to be discussing the recursion function. Recursion in computer science is a method where the solution to a problem depends on solutions to smaller instances of the same problem. Later in this video we're going to see the differences between recursion and iteration. Let me start with an example. One of the main examples for recursion might be factorial. So let's say we have factorial 5. This is going to equal 5 times 4 times 3 times 2 times 1. If we do 4 factorial, we might do 4 times 3 times 2 times 1. Now, I want you to notice that the 4 factorial is also included in the 5 factorial. So we have this definition of 4 factorial, it's included inside the 5 factorial. So maybe we rewrite this 5 factorial as simply 5 times 4 factorial. Similarly, for 4 factorial, we have the definition of a 3 factorial inside of 4 factorial. So we could rewrite this as 4 times 3 factorial. So if we follow this kind of similar structure, we might find that for any number n, we have n times n minus 1 factorial. Now this is going to be a classic problem you could use for a recursive function because we have smaller instances of the problem within a larger problem. So we can break down 5 factorial into 4 factorial, break down 4 factorial into 3 factorial, we can break down 3 into 2 factorial, and 2 into 1. So we'll see the code in a bit. Another example we could use is an exponential power function. In this function, we're going to take 2 variables and we're going to spit out x to the y. So like if we input x and y, then it will output x to the y. So let's just one example, maybe power x 2 comma 4 is going to equal 2 to the 4. So in computer science, maybe we want to break this down to just multiplication. So this is going to actually equal 2 times 2 times 2 times 2. In this case, where could we break this problem down is here. 2 times 2 times 2 times 2 is equal to 2 times 2 to the third. So we can break this down a little smaller. Equals 2 times 2 to the third, which that is going to translate to 2 times the power of 2 to the third. Now, if we want to further investigate this, if we do power 2 to 2, we can get 2 times 2 times 2, which is going to translate to 2 times power of 2. Now this continues on. We should reach some power that is equal to 1, in which case we'll just return the base constant. And we'll see that in a bit. I'm going to go ahead and switch over to the code. All right. So we do Factorial example. Start with the iterative approach. So we're going to define a function factorial which takes some number n. So for I range n, I have to apply some factorial times that number. Now we have to define this first as maybe 1. Return that function factorial sorry about that. All right, so what's going on in this iterative approach is that we define some number n. So say we start with 5 and we're going to range through the values 1 to 5. So now we're going to multiply that factorial by 1, then 2, then 3, then 4, then 5. The recursive approach going to see that this approach is going to be a lot easier. So get factorial 1 and return 1. Otherwise, return n. And there you go. Let me just say we change this number to 10. And we'll see that these two processes are exactly the same. All right, so let's move on to the power function example. And define, start off with the iterative approach. All right, so for this approach, we're going to have to multiply x, y times. Now I'm going to go ahead and go through some range of numbers. The power function is going to be y. Starting with 1. Zero. Y minus 1. Now I'm going to put r is equal to 1. So if it's going to be x to the 0, we should return a 1. So 0 minus 1. 0 minus 0 should equal 0. So It's not going to go through the for loop. Multiply this by y. Then I'm going to go ahead and print example of this. Power function 2 to 4. We should get 16. Awesome. All right, now for the recursive approach, we're going to break down the problem. We're going to return something times the power of x comma y minus 1, as you can see here. Some power of x comma y is equal to x times the power of x comma y minus 1. So this is what we're going to be showing here. Now we have to define where the recursive function stops, and this is what's called the base case. So in the factorial approach, the base case would be if n is less than or equal to 1, and that's where we could stop the factorial. So if n is equal to 1, then we stop. For the power function, it's going to be a little bit different. If y is equal to 0, then we're going to return 1. X to the 0 is going to always equal 1. So if y, this means that if y is not equal to 1, then I'm going to return following. Otherwise, if y is equal to 0, then we're going to return 1. All right, so now we get 16 and 16. Now if we want to adjust these values, we'll see that these functions are similar. They're going to give the same result. All right, so we have two examples of the recursive and the recursive approach. We have one of the factorial and one of the power function. Why would we want to use the recursive approach as opposed to the iterative approach? And this answer is because it keeps it simpler. We could write less code. In these instances, these examples are really simple, so you're not going to see the huge benefit. But in some instances, it's going to require a lot less code if we write it in the recursive approach as opposed to the iterative approach. Thank you.